Thank you for introduction. I'm Hiroki Kitagawa from Hiroshima University in Japan. Today I talk about inactivation of airborne SARS CoV-2 by 222 nanometer Far-UVC radiation. SARS CoV-2 is transmitted by droplets, aerosols, and contact. And the viral SARS CoV-2 was detected from the surface and the air samples collected near a patient with COVID-19 patient. Previous reports showed the inactivation effect of 222 nanometer UVC on SARS CoV-2 on dry surface and in solution. However, there's no report about the inactivation effect of 222 nanometer UVC on aerosolized SARS CoV-2. We previously reported the effect of 222 nanometer UVC for disinfecting surfaces contaminated with the SARS CoV-2. 1 millijoule per square centimeter 222 nanometer UVC reduces 88.5% of SARS CoV-2. This is me. We also investigate the effect of the Far-UVC on the shared bathroom. This is the we equipped the Far-UVC lamp here. This is a shared bathroom, and I'm sitting here. The automated 222 nanometer UVC disinfection device. This device has a motion sensor, significantly reduce the aerobic bacterial surface contamination of the shared bathroom. In this study, Far-UVC lamp is on only there's no people. So we have this device has a motion sensor. So the light is when the people use the toilet, the lamp is off, and when people move go out the toilet, the lamps get on again. This is a stamp cultures pictures. We also investigate about the hospital use only mobile phones. This hospital use only mobile phone is usually used in Japanese hospital. We showed this mobile phone is contaminated with MRSA, and Far-UVC lamp result in the effective in vitro reduction of MRSA and significantly reduced aerobic bacterial contamination of these mobile phones. Okay, the aim of this study is to evaluate the inactivation effect of 222 nanometer UVC on aerosolized SARS-CoV-2 and SARS-CoV-2 in solutions. We use a wild type SARS-CoV-2, and the infection titer was measured TCID50 method. And we use 5UVC lamp, KR222, produced by the Ushio. The oral experiment with SARS-CoV-2 was conducted in the biosafety level 3 laboratory in our university. We make a custom-built UV irradiation chamber based on the previous report from the Brenner's study group. This chamber has a nebulizer and UV transmitting window the box. This area, the particle are disinfected by the Far-UVC, and we use a gelatin filter to detect to sampling. We investigate the two positions of the Far-UVC lamp, 90 centimeter and 30 centimeter away from the window. This is a photograph of the chamber. Our chamber is a little bit big, so we can't use a biosafety cabinet. So we make a acrylic glow box. The all air in and out is filtered by the HEPA filters. This is a nebulizer, and this area is a UV exposure area. The particle from the left to right move, and the 0-inch filter collects the particles. For our UVC lamp is 2 positions, 90 centimeter and 30 centimeter away from the window. The UV transmitting window, the box like here, the volume is 4.6 liter and the flow rate is 18 liter per minute. So the particles receive your Far-UVC about 15 seconds. So the total exposure dose of the particle were 0.90 and 1.67 millijoule per square centimeters. This figure shows the inactivation rate constant for the aerosolized SARS CoV-2. The K value is 1.14. This is almost same that of our previous report about the SARS CoV-2 on dry surface. Next, we performed the UV exposure experiment for the SARS CoV-2 in solutions. We use a SARS CoV-2 solution of in DMAM without FCS was used. The viral stock solution is prepared for diluted 10-fold and 100-fold in PBS. We use 1 milliliter SARS-CoV samples under a 35 millimeter diameter dish. This figure shows the inactivation rate of the SARS-CoV-2 in DMAM diluted to the 10-fold in PBS. K value is 0.73, and this is SARS-CoV-2 in DMAM diluted to 100-fold in PBS. K value is 1.04. This is higher than the SARS-CoV-2 in DMAM in diluted the 10-fold in PBS. This is a calculated inactivation rate constant of the SARS-CoV-2 on dry surface. This is based on our previous report. K value is 1.05. It is similar of the aerosolized and SARS-CoV-2 in solutions. Discussion and the inactivation effect of 222 nanometer UVC on aerosolized SARS-CoV-2 was similar on the SARS-CoV-2 on dry surface and SARS-CoV-2 in DMAM diluted of 10-fold in PBS. And the inactivation effect of the 222 nanometer on SARS-CoV-2 in DMAM is diluted to the 10-fold in PBS was higher than that of the 10-fold in PBS. One possible explanation of this difference due to the sample absorbance of the 222 nanometer UVC. Our result is a recent work with the 222 nanometer UVC inactivation in SARS-CoV-2 in the solution shows a similar result or compared to our result. However, the one report is a little bit different. This inactivation effect of SARS-CoV-2 are much higher than the reported by Robinson's. This could be also explained by the difference of sample absorbance at the 222 nanometer UVC. The previous report also demonstrates the efficacy of the inactivation of 222 nanometer UVC for airborne viruses, influenza and the human coronavirus 229E and the ORC43. Inactivation rate constant of SARS-CoV-2 in our study is less than that of these reports. However, this difference may be due to the difference in the experimental conditions. Conclusions, inactivation effect of 222 nanometer UVC on aerosolized SARS-CoV-2 was found to be similar to that on SARS-CoV-2 on dry surface. and SARS-CoV-2 in DMEM diluted tenfold in PBS. Inactivation effect of 222 nanometer UVC on SARS-CoV-2 aerosol need to be verified in the real environment. This is our hospital. This is a room. Some of patient room equipped the Far-UVC lamp. Now we are investigating the effect of the real world. Thank you very much.
Any questions?
Thank you for your presentation. I have a question. In your study, you found the aerosol SARS-CoV-2 and the SARS-CoV-2 on the surface had the same disinfection efficiency. But I'm curious about for the SARS-CoV-2 virus in the air, it will be evenly and well mixed in your experiment. But in the surface, the virus may overlap with each other and block the UV light. So could you explain why this aerosol and surface disinfection has the same result?
Yes, thank you very much for good questions. I think the dried surface is our solvents is less than the in solutions. I think aerosol is a very small particle, and the dry surface is always the absorbance of less than the in solutions. I think so. The inactivation effect of the SARS-CoV-2 in DMEM in the tenfold PBS is less than the 100-fold in the PBS. So I think that's the reason.
Okay, let's thank our speaker once again.